Okay, so you know how you go to the doctor and they say, we need to get an MRI, you slide into that tube and it feels so high-tech, so safe.
Right.
But what if I told you there might be some, hidden stuff going on deep down at the cellular level?
Ooh, that sounds intriguing.
Yeah, and that's what we're diving into today. There's some really interesting research out of the University of New Mexico, and they're looking into how gadolinium, that metal they use in the contrast, dye for
To
MRIs.
make the images clearer, right?
Exactly, to make those images pop. But they're finding that it might actually form these teeny, tiny particles, nanoparticles, inside our bodies.
Huh. So even though MRIs are super helpful and generally safe, there's this whole other layer of complexity that we're just starting to understand.
Totally. And it makes you think about how each of us responds to medical stuff so differently. Like, usually the gadolinium is bound to other molecules, and your body just flushes it out, no problem.
Right, that's the idea.
But researchers have been finding traces of gadolinium, like lingering in the kidneys and the brain, years after an MRI.
And not just in people who had side effects, right?
Yeah, even in people who felt totally fine afterward. It's wild.
So that's why they use contrast agents in the first place, right?
Mm.
To get those super crisp MRI pictures, help doctors spot any issues.
Right, these agents are essential tools.
But those gadolinium particles hanging around, it's always been a bit of a mystery.
A bit of a medical cliffhanger. So that's our mission for this deep dive. We've got this new paper in magnetic resonance imaging, hot off the press, and some great reporting from Michael Herrla at the University of New Mexico.
Sounds like a solid foundation for our investigation.
We're going to break down how these gadolinium nanoparticles might be forming, why it could be an issue, and what the researchers are suggesting we do about it.
It's like zooming in on this tiny invisible world with potentially huge implications.
Exactly. So, you know how gadolinium-based contrast brightens up tissues in an MRI, helps doctors see what's going on?
Yeah, it makes everything more visible.
And normally it's supposed to just exit the body without any drama.
Right, a smooth exit.
But then there's this condition called nephrogenic systemic fibrosis, or NSF. Have you heard of it?
I have. And it's not pretty.
No, it's serious stuff. Like, the skin thickens and hardens, it affects the heart and lungs, causes these awful joint problems.
Yeah, incredibly debilitating.
And here's the scary part. The researchers found that almost half the people who got NSF had only had one exposure to these contrast agents.
Just one. Wow, that raises some serious questions.
It suggests there's some sort of amplification happening in some people, like
Yeah.
one dose triggers this cascade of problems.
Domino effect.
Yeah, exactly. So the researchers at the University of New Mexico, they started looking into how these gadolinium atoms might be breaking free from the bigger molecules they're attached to and clumping together to form these tiny nanoparticles.
So we're talking about little bits of metal forming inside our cells.
Yeah, it's pretty mind-blowing when you think about it, and obviously not great for cellular health.
Definitely not ideal. It's like your body's alarm system goes off when it detects something that shouldn't be there.
Right, tries to fight it off. And in some people, that response can be way too strong, leading to conditions like NSF.
The body's defense is backfiring, essentially.
Now, here's where things get really interesting. The researchers started looking at oxalic acid as a possible culprit.
Oxalic acid. Okay, I'm intrigued. Tell me more.
So for those of us who haven't taken a chemistry class in a while, what exactly is oxalic acid? What made the researchers suspect it?
Oxalic acid is this fascinating little molecule, and you find it in tons of plant-based foods. Things like spinach, rhubarb, nuts, berries, even chocolate.
Oh, wow, I had no idea.
Yeah, it's everywhere. And here's another interesting tidbit. Our bodies actually produce oxalic acid when we process vitamin C. So
Okay.
it's not just from what we eat, it's also something our bodies naturally make.
So it's not some obscure chemical, but something we encounter all the time.
Precisely. It's part of our everyday lives.
Okay, so that's oxalic acid. But what's the link between this common molecule and the gadolinium in MRI contrast?
Well, oxalic acid has a thing for metals. It loves to bind with them.
Like a little metal magnet.
Exactly. And that's why some people get kidney stones, actually. Oxalic acid in the urine binds with calcium, and boom, kidney stone.
Ouch. So the researchers thought, could oxalic acid be messing with the gadolinium and the contrast agents too?
That was their hunch. They
Okay.
thought maybe it was pulling the gadolinium away from those molecules it's supposed to be bound to, causing it to go rogue.
And were they right? What happened when they tested it out in the lab?
So in their experiments, they added oxalic acid to a gadolinium-based contrast agent. And guess what?
I'm on the edge of my seat.
They saw that some of the gadolinium started to separate out of the solution and form these tiny solid particles, nanoparticles.
It's like when you add something to a liquid and those tiny bits start to appear.
Right. Precisely. That's what the oxalic acid was doing to the gadolinium. And here's the kicker. They saw these newly formed nanoparticles actually getting inside the cells of different organs.
Whoa, so it's not just floating around harmlessly, it's breaking free and invading cells.
Exactly. That's why the body might freak out in some cases. It's not just the presence of the metal, it's the fact that it's changed form and gotten into places it shouldn't be.
That makes total sense. So this brings us back to the big question. Why do some people get these awful side effects from contrast agents, while most are fine?
The million-dollar question.
And the researchers think the answer might lie in what they call an individual's metabolic milieu.
Sounds fancy. What does that even mean?
Basically, it's the overall chemical environment inside your body at any given time.
Like a unique internal cocktail.
Yeah. So the researchers think that if someone has a lot of oxalic acid in their system, maybe because of their diet or because they've been taking a lot of vitamin C.
Which the body turns into oxalic acid, right?
Exactly. Or if they have other molecules that like to bind with gadolinium floating around, that could create the perfect storm for these nanoparticles to form.
It's like having all the right ingredients for a chemical reaction.
And that reaction could be bad news.
Right. So it's not just about the contrast agent itself. It's about the unique internal environment of each person.
Which is why some people have these horrible reactions while others sail through with no issues.
It's personalized medicine in action.
And the good news is that this research isn't just about identifying a problem, it's about finding solutions.
Right.
What are the researchers suggesting we do with this new information?
Well, one of the researchers, Dr. Wagner, had a pretty straightforward suggestion. He said, I wouldn't take vitamin C if I needed to have an MRI with contrast.
Seriously, just skip the vitamin C.
Because of how the metal reacts, yeah.
Huh. So even something as seemingly harmless as a vitamin could mess things up.
It's all about those unexpected interactions.
What else are the researchers doing?
They're really focused on figuring out who's most at risk. So they've started this huge international patient registry.
Like a database of cases.
Exactly. They're collecting samples, blood, urine, fingernails, hair from people who had bad reactions after a contrast-enhanced MRI.
To see if there are any common threads, any clues.
Precisely. They want to see if there are any patterns that might point to a higher risk of gadolinium buildup or nanoparticle formation.
So they're building this massive puzzle and trying to find all the missing pieces. What kind of information are they collecting in this registry?
Pretty much everything you can think of. Medical history, any pre-existing conditions, all medications, and really detailed info about any dietary supplements they're taking.
It's like a detective story, trying to piece together all the clues.
Exactly. And they hope that by analyzing all this data, they'll finally understand why some people get symptoms and others don't.
It's amazing how much we're learning about these subtle interactions. So, to wrap things up, what's the big takeaway from our deep dive into gadolinium and oxalic acid?
The key point is that oxalic acid, something we eat and produce naturally, can potentially cause the gadolinium in MRI contrast agents to break free and form nanoparticles. And those nanoparticles might be causing trouble in some people.
And this research helps explain why some folks have bad reactions to contrast agents, even after just one dose. It's not always about the contrast itself, it's about how it interacts with each person's unique biochemistry.
And that's what makes this research so important. It's all about personalized medicine, understanding individual responses to medical treatments.
And hopefully it'll lead to better ways to identify those at risk and make MRIs even safer.
That's the goal, to make sure everyone benefits from this incredible technology without any unexpected consequences.
You know, it's mind-blowing to think that something as simple as what we eat can affect how our bodies respond to medical procedures. It makes you appreciate just how complex and interconnected everything is.
Absolutely. And it makes you wonder what other dietary factors might be playing a role in our health that we haven't even discovered yet.
It's a whole new frontier of personalized health, and it's incredibly exciting to see where it leads. And that's something for all of you listening to ponder. What seemingly harmless things in your daily life might be interacting with medical treatments in ways we don't yet understand? It's a fascinating question to consider as we continue to unravel the mysteries of the human body.